Hello. Welcome to the Legacy Data Conversion Workshop presented by Business and Decision Life Sciences. I'm Stephen Bamford and I will be moderating this webinar. Our speakers today are Anne-Sophie Becks, Senior Project Manager, and Peter Van Roozel, Chief Operations Officer, both at Business and Decision Life Sciences. Both are industry experts in CDISC data standards, and some of you have met Peter and myself on a recent trip to Japan. A few technical notes about this webinar before we start. As this is a broadcast webinar, everyone is in listen-only mode. You can use the panels on the right-hand side of your screen to communicate with us. If you cannot view the screen, drag the bottom right-hand corner of your screen window to enlarge. This webinar is being recorded and you will be sent a copy of the recording within the next week. You will also receive a copy of the slides that will be presented today in case you miss any of the information. There will be time for a question and answer session following the presentation. You can ask questions using the box on the right-hand side of your screen. At the end of the session, you will be sent a feedback form. Feedback is very important to us at Business and Decision, and it will help us when organizing future webinars. If you would like further information on how Business and Decision Life Sciences can help your company with legacy data conversions, please contact me via my email to request a meeting. CDISC has been around since early 2000, and the FDA is very keen on its use. Recently, PMDA have announced that all submissions from 2016 can be submitted in CDISC format. Business and Decision has helped many companies in Europe and America with their data conversions ahead of drug submissions. This service will be very important now in Japan, as we are almost in 2015. Now is the time to start planning data conversions. Over the next hour, you will learn about how we approach legacy data conversions. First, I will give a brief overview of Business and Decision Life Sciences before handing over to Anne-Sophie, who will talk you through the main part of the presentation. Business and Decision Group was founded in 1992. It has over 2,500 employees. It has a presence in over 15 countries and is listed on the French Stock Exchange. Business and Decision Life Sciences is part of the Business and Decision Group and has been launched since 2007. It has over 250 employees based mainly in Europe. It has offices in Africa, Europe, and North America. We work with many companies around the world and are trusted by all these companies that you see on the screen. We have a deep relationship with CDISC and with the FDA. Peter Van Roozel is the chair of the European CDISC Coordinating Committee, and we hold all of the training for CDISC in Europe. We are a principal member of the education team for CDISC, and we have previously chaired the advisory board. We have full representation across many of the CDISC streams, including SCTM, CDASH, and XML technologies. As a CRO, we work from project setup right the way through to submission. The services we offer are what you expect from a lot of CROs, including data management, biostatistics, stat programming, and CDISC submission work. However, we are well known throughout the whole industry for our CDISC work. We do CDISC data conversions, both SCTM and ADAM. We can do roadmap preparation for your company, and we can implement your data standards within your company. We have a number of e-clinical applications. Some of you have already seen CDMation and Define It, and we can talk about these at a future time should you wish. We have a lot of experience of supporting regulatory submissions and legacy data conversions, mainly around the FDA, but a lot of what the FDA are currently propose PMDA will also require exactly the same. We can work on your SDTM annotated CRFs and datasets, your ADAM datasets, any pooled analysis for an integrated safety summary or efficacy summary. We can produce the defined.xml documents ready for submission, as well as any data handling reports or FDA reviewer guides. All of these are components that you will be required to have in place for your CDISC data submissions within 12 to 18 months' time. When we look at our global implementation services, we can do this on a consultancy basis for you. We can help you create a CDISC compliant standard CRF library, and we can also help you build a metadata repository that will help you save timelines and increase quality and your adherence to CDISC data standards. We can also help with the generation of any SAS reporting macros for any ADAM dataset generation or any ISS and ISE submission work that you require. We can work with small or large companies, we can work with CROs, and we are platform independent. I'm now going to pass over to Anne-Sophie, who will now run through the preparing your conversion to CDISC part of the presentation.
Thank you very much. Okay. So, firstly, we'll need to talk about the ECTD structure, which you've seen in one of Stephen's previous slides. So what you'll need for your regulatory submission is, first of all, the CDISC standards, of course. The format of electronic data required for submission will be SDTM and ADAM in the case of the PMDA. You will also need to submit a defined.xml for both SDTM and ADAM datasets. You will also need to provide electronic data on ISS and ISE if required. So these datasets are based on ADAM, its definition file, and the programs for creating these datasets. Now, for all of these, it is recommended that you would individually consult with the PMDA and the division you would be submitting to and ask them really what it is they would like you to submit for your studies. The first thing is also to see which structure they would like their electronic submissions to be in. Now, the ECTD structure is used by the FDA for the moment for all electronic regulatory submission. However, the PMDA still needs to confirm whether or not they will also require this structure. So, as you can see on the screen, this is the type of package that gets submitted to the FDA. And this will need to be confirmed for the PMDA. The same is true for the ADAM, which also has a specific ECTD structure to follow for FDA submissions, as you can see on the screen. The important thing to note is that when you are submitting both SDTM and ADAM, as is requested by the PMDA, a very important part is the traceability between these two models. So we need to understand the relationship that exists between analysis results, analysis datasets, and SDTM domains. And we basically need to establish a path between an element and its immediate predecessors. Now, there are two levels of traceability, at your metadata level and at the data point level. So traceability goes from your analysis results. So, for example, a table that represents some vital signs for a subject, to the analysis dataset, which is really the ADAM dataset that contains the results. And this needs to be linked back to an ADAM-define.xml, where you will be able to specify the metadata around this result. And this can be linked back to a define.xml that was made for SDTM datasets, which in turn can be linked back to your annotated CRF. So you'll see that you have complete traceability between the point at which the data was collected on your CRF all the way to the tables, figures, and listings you are creating based on that data. So if we show this in a bit more detail, you'll see here an analysis results table, which contains some BMI information. And if you go and look in your ADAM analysis dataset, you will find this BMI data in a ADAM format. At the level of the define, you will be able to see that this BMI has a computational algorithm associated to it. ADSL.BMI. And you can click on that hyperlink to see which algorithm is being used. And you see in the algorithm that we are using weight and height, which are both taken from SDTM datasets, vs.vs_n. And this is how you make your link to your SDTM data define.xml, which will contain this vs_n for various test codes. And clicking on the hyperlink for your VS test code, you will be able to find exactly which CRS page they were taken from. So there we've made the complete link again, and we have complete traceability between your SDTM, your ADAM, and your analysis results, which is a very important part for the submission. So if we look at an SDTM data conversion, this is a very general overview of how it works. You get your source CRF, clinical database, an analysis database, and you do an SDTM conversion to create an SDTM annotated CRF, an SDTM clinical database, and a define.xml. Now, to ensure traceability, there are two approaches. The first approach would be to generate your SDTM datasets from your clinical database, and from your SDTM datasets, generate ADAM datasets and analysis results. And at the end, compare the statistical output you get from that with the statistical output that you obtained from your analysis results preparation. Now, the advantage of this method is that you ensure complete traceability, but it is very time consuming and you will need to reprogram all analysis and analysis results. The second approach would be to generate your SDTM datasets from your clinical database and to generate your ADAM and statistical outputs from your analysis database. Now, the advantage of this method is that it's a lot quicker, but you need to ensure traceability retrospectively, which can be quite complex and may not always be possible. So that's something to think about when starting up your SDTM and ADAM conversions. On the longer term, of course, we need to start looking at CDISC model integration. Now, this means that we would implement standards upfront. So data collection would be using the CDISC model, tabulation would be using the SDTM model, and analysis would be done using the ADAM model, and all of its metadata represented in define.xml with CDISC control terminology used throughout. Now, the advantage of this, of course, is that you increase your data quality and reduce submission cycle times because there's no need for conversion as your data is already in a CDISC format when you collect it. And there's a very great deal of data terminology transparency. Now, the main drawbacks, of course, are that it's a very large one-time investment and that it requires time and money and resources because the integration of legacy systems, and you need to take into account the integration of legacy systems and processes and how to work around that to implement a CDISC model. The next part of the presentation, I will go through the CDISC conversion methodology that we use here at Business and Decision Life Sciences, followed up by a demo of one of the tools that we're using for it. So, regulatory submissions require the following deliverables: an SDTM annotated CRF, SDTM datasets, ADAM datasets, define.xml, and an eCTD structure. Usually the teams that would work on these type of projects are of very varying profiles. We need a project manager to guide the team. Then we have data integration specialists that we call mappers. These are SDTM experts. Programmers to create conversion programmers and statistical programs as the ADAM experts, and some statisticians, of course, for the generation of your TFLs. And then we like to also have a person assigned to the role of data steward to maintain consistency across a project, because that's also very important for a submission, is that within a submission you are consistent in the way you have handled and approached your data. Now, there are certain things to define upfront before you start your conversion. First of all, you need to choose a base model of SDTM. Now, the latest version is 3.2, but a lot of our sponsors are still converting to 3.1.3, as this is still accepted by the FDA and will be accepted by the FDA for quite some time still. You need to select a therapeutic area user guide if it's applicable to your submission. For example, if you have a submission for an asthma drug, you will need to use the therapeutic area user guide for asthma that has been developed by CDISC. You will need to choose your version of CDISC control terminology, your version of define, and also your version of ADAM and any ADAM supplements that have been released. Now, as you've seen, CDISC models have grown exponentially over the past few years. And so data governance becomes quite important, because as you will see from this slide, the past few years have really seen an explosion in the development of CDISC models. It looks a bit scary, but with proper planning, data governance can be achieved. So the first thing to do is to create your SDTM annotated CRFs, as most of your maps are made when you start to annotate a CRF. This is really where you're going to decide which SDTM datasets you will need to create. You will then need to define a mapping. This is what we do here. So we map in a big Excel file source data to target SDTM data. And this mapping is used to create the conversion jobs in CDISC Studio, which is what we use to program, and it's used to generate the define.xml, so your metadata. So we have a metadata process that we've developed in CDISC Studio. So basically what we do is we import mapping specifications and source data together with global standards that are present into a metadata repository. And from this we can extract the define.xml and generate SDTM and ADAM datasets. So now I will hand over to Peter, who will provide the demo for CDISC Data Integration Studio.
Okay, great. Thank you, Anne-Sophie.
I'll pass it over to you. Hold on. Check it, I can still hear you.
Show my screen. Can you see my screen? Okay, great.
Check if someone can hear you. Someone put a chat in thing so
So, great, Anne-Sophie, so let me take over. It is really my pleasure to show you or to share with you our methodology. Yeah? As most of you know, Business and Decision Life Sciences, we have been doing these CDISC, SETM and ADAM conversion already since 2008. Over the years, we have worked on hundreds of studies, on a large number of submissions to the FDA. We work with many different clients out there. So this really gives us the opportunity, or it gave us the opportunity over the years to develop our conversion methodology. And it's really my pleasure to share with you on how exactly we are doing that at Business and Decision. Yeah? Generally spoken, I could say that about 70% of the effort of a conversion is really going into the mapping. Yeah? So that mapping file that you see over there, yeah, typical folder, that's something I'm going to show you. 70% of the time is going into a mapping, and the people who do this, the people who basically do this are what we call data integration specialists. Starting from this map, using here is called SAS Data Integration Studio, but you don't really have to use this tool. Other companies are using maybe base SAS or are using macros, and also other ETL tools are available. ETL tools stand for extract, transform, and load. But what I would like to show you now specifically is in that tool, how did we set up our programming environment and our mapping environment. So I've already started up the tool, and our tool looks a little bit like this. Oops, I need to minimize this part. Here we go. So our tool looks a little bit like this. Yeah? Over here, what can you see? You can see folders, inventory, transformation. You can see a number of folders. In any of these types of tools, you can choose the folder structure. Yeah? And there are two folders where I want to bring your attention. On the one hand, there is a folder called Global Standards, and then there is a folder called 1033. 1033, that is in this case our project folder. With a project, with any conversions, when we are doing a conversion, usually we're converting multiple studies, because typically we would convert not one or two studies, we're converting all of the studies for a certain submission. Yeah? And what we've chosen to do is to create a folder per project, yeah, with multiple studies in there. But first, let's have a quick look at global standards over here. So what did we do? In this environment, in this tool, we ensured that all of our global standards, yeah, are available. Okay, so if I open the folder SETM 3.2 Global Standards, what can I see? I can see a subfolder with the model. Yeah. So when I look at my SETM model, version 3.2, you will also find a section with all classes, a section with events, a section with interventions, and all of that metadata we've made available in this environment. I'm going to show you also the SETM IG, the implementation guide. Basically, that implementation guide is a document. In that document, you will find all of the metadata for all of my different tables, as you can see. And all of that metadata we have made available in this environment. So, for example, when I click on adverse events and I right-click on properties, yeah, at this point in time, I can see adverse event properties, and I can find all of my columns. So again, all of the metadata from the implementation guide has all been imported into this environment. Why do we do that? Because we're going to use them as, at some point in time, we're going to create target tables. Yeah? And we're going to use this as an input. So all of the metadata that our programmers need is already there to get started. For example, when they're going to create a new AE, an adverse event target table, typically they would start from this. They would start from this and simply add or remove the variables that they need or not need. Okay. So I'll close down the global standards part. As you can see, we also ensure that global terminology, yeah, that all of the code list information is also available over here. So basically all of the metadata that I need during my conversion. I'm trying to ensure that all this metadata is available in my programming environment. Okay? So, enough about the standards. Let's have a look at our project folder. We have chosen the folder structure for our project folder, and as you can see, it's quite simple. On the one hand, there's target data. Yeah? Maybe we should really start with the source data. On the one hand, there's source data. This source data, what we're actually going to do is from a certain study, in this case, study XXXXXX, yeah, we're going to import all of the metadata for all of the tables within a certain study. So all of the metadata and the data is in here. Okay, that's source data. There will also be a folder called target data, because on the one hand I have the source tables, on the other hand there are going to be a number of target tables. So when I open that up, you can start seeing that this is very recognizable. Adverse events, demographics, these are my SDTM datasets. And then the fun part, between source and target, we have our jobs. Our jobs, which are really our macros, our programs. So I'll come back to this a little bit later. So let me get started with source data. This is an example. This has been blinded data, in fact. Yeah. This is an example of source data. Now that source data could be in multiple formats. Most of the time, I would say 90% of the work that we do when we receive datasets from our sponsors, 90% of the time, these are going to be SAS datasets. Yeah. So SAS datasets, a very easy structure. What we typically do is we import that metadata in this environment. From time to time, it's also possible that we need to work with EDC extracts, an extract from an EDC system. It works equally well. And we will import, I would say, the definition of that extract in this environment. I'm going to show you two examples. For example, PAT-D. PAT-D, simple table, it's the patient table. Yeah? So when I open the properties over here, I can see the structure. Yeah? You can see the structure of the patient table and all of the metadata that's coming from the source table. Some of you may recognize when you look at the variables called study, PT, PTNO, TPAT, doc submission number, that these, or doc subset number, that these variables are really, this is really an extract from Oracle Clinical. So Oracle Clinical, data collection tool or data capture tool, and this happens to be an extract from Oracle Clinical. Yeah. When I double click, or sorry, when I open this, I can actually see the data. See? So over here I can see my patient table. In this case, this is a study of about 242 patients. So there's quite some data in there. You can see patient identifiers, you can see investigator names, and then when I scroll a little bit further, you can see in this case, yeah, the formats. The formats have actually been removed already at this point in time, but you can see a number of variables: height, weight, and also BMI. Now when you think about it, in this case, our source table is containing the variables called height, weight, and BMI. Yeah? I already know that those three variables, I'm going to need them to extract them or to read them from the patient table, and I'm going to need to convert them. I'm going to need to convert these variables into value level metadata into records in the vital signs table. So all of these variables, yeah, will become records in my vital signs table later on. Okay. Let's also have a look at that vital signs table, because there is a VIT table over there. Vital signs. Yeah. This is still source data. And if I look at the data, again, my patient identifiers, and then here you can see my systolic blood pressure, diastolic blood pressure, and also my heart rate. Yeah. Again, over here, I already know that every record over here is containing three variables: systolic blood pressure, diastolic blood pressure, and heart rate. Now, these three variables at some point in time need to be transposed into records. Yeah. So for these three variables in the vital signs table, I will have three resulting records. So this is my source data. Okay. To start from. Let's move on to the target data. So the target data, that's really where our programmers, once our data integration specialists, once our mappers have done the mapping, that's when our programmers really start creating the target data. So in principle, they're going to start creating the shell. The shell or the definition of a target table. What I can do, for example, adverse events, I right-click this, click on properties again, and over here, you can already see that all of the metadata that we need for this target table is in there. Now you can see some metadata, such as the variable name, description, the type, length, format. However, there is more metadata. For example, if I right-click on term in this case, I can have a look at properties in here, and I can see that there are a number of extended attributes. With these extended attributes in this tool, what we're actually doing is we're adding more metadata to this specific variable. In this study, we can see that the core designator is required. The origin, specifically for this study, is CRF page 4. Role is topic. Yeah. From time to time, it's also possible, let's see if we have that in there. Over here you can see notes. This is something recognizable. Unique subject ID variable has a fixed format, and it's telling me about the format. This metadata eventually is all going to be extracted into a define.xml, and this is actually going to be the comment of a define.xml. All of the other metadata, over here you can see the extended attributes of the AE table. These extended attributes have been metadata loaded into my environment, and later on, I'm going to extract all this metadata into a defined XML. And in this environment, I'm going to use that metadata to convert my data. Now the question could be, how does that metadata get here? Do the programmers type that in manually? No. Actually, what's happening is all of this metadata is being read in automatically. And now I'm going out of the tool for a second, and I'm going to show you our mapping table. This mapping table really is the driver of our conversion methodology. Yeah. So I'm going to wait for a second until it opens up. Here we go. And this is a mapping table. As you can see, it's a mapping table on which people worked, and there are some colors in there, and there are some shades in there. But what can we see over here? In this particular tab, we can see all of the metadata for an SETM dataset. Yeah? So all of my SETM datasets, in my conversion, all of the metadata has been listed here. In fact, all this metadata will be read into the tool. So I've just shown you. I'm going to quickly scroll back, if you allow me. When I look at that adverse event properties, and I'm going to look at the extended attributes, that metadata right there has been read from that Excel sheet, from the mapping sheet. Yeah. So our mappers, usually they're data managers, the people who really understand the source data, really understand the CRS and SETM. They are going to enter this information right there. Yeah. Over here you can see a mapping sheet for my SETM variables. What you can see is two parts. On the left-hand side of the screen, you can see all of the target data. On the right-hand side, you can see the source data. Now, as you can see, it's quite a busy slide. There are a number of codes in there, and I'm going to draw your attention to a number of variables. For example, over here there's a variable called AESEV, or AE severity. And what can I see? I see that there's a source variable called, in this case, AEINT. And there's a code list attached, AEINT1F. In fact, between those two variables, there's going to be a one-to-one conversion. See, when there's an X in this particular field, this is a code which is telling our programmers this is a one-to-one conversion. So if we're going from one variable to another variable. Yeah. However, we are going to need to do a code list conversion between AEINT1F and AESEV. We can also see that there's a code list attached, the AESEV code list. We can also see that I'm adding more metadata here. The origin AESEV is coming from the CRF on page 4. See? I'm adding some comments over here. So what we can really see on this mapping sheet is two things. On the one hand, there is this mapping information over here. Yeah. On the other hand, there is already metadata eventually for my define XML. One more example. Over here I can see two variables, AE onset date or AE start date and AE end date. What do I need to do with this variable? Again, it's a date conversion in this case. So over here I'm creating a reference ISO 8601. And my system understands by just looking at this flag that this is going to be an ISO 8601 date time conversion. The system will almost do that automatically. What else can I find in my mapping sheet? Value level metadata. I've just shown you the example and I already filtered on vital signs. In the example we have just shown, you know that there is a source table called PATD. There are three variables in there: height, weight, and BMI. I know I need to convert them, or I need to transpose them into value level metadata, into height, weight, and body mass index. So this is the CDISC conversion part. I also know that in my vital signs table, there are three variables: systolic blood pressure, diastolic blood pressure, and heart rate. And actually I need to convert this into SysBP, DiaBP, and pulse. So this part of the mapping sheet will be read into my environment, and this is going to feed an automatic transpose mechanism. And that's something I'm going to show you a little bit later. So our programmers are not going to take every single variable and program every height or weight into a transpose. No, this entire table, in fact, which is, when I unfilter, a very, very long table of value level metadata, if you see what I mean. Yeah. All of this is going to be transposed automatically. Yeah. Now, this mapping sheet has two purposes. This is the mapping information, but when I look a little bit further, there's also additional metadata there. This metadata, which you see here, is actually metadata which I'm going to use later on to put in my define XML. And that's something I'm also going to demonstrate. What else do we have? Supplemental qualifiers. See? So the non-standard variables, supplemental qualifiers, all of these variables that you can see on the left-hand side are all non-standard variables. So that means I need to automatically transpose them into supplemental qualifiers. And this entire table is automating that. See? So on the one hand, this is the information saying, for example, there's an AE derived end date. The derived end date, so not the real end date, but a derived end date, that is a non-standard variable. So this variable is going to be automatically transposed into this record, into a record in sub AE, where the QNAM is DRV ENDT. And in addition, also for supplemental qualifiers, I'm creating additional metadata. Yeah? More information, code list metadata. Over here I can see my automatic code list conversions. Yeah? So over here you can see that these are the original codes. In my data I will find codes like 0, 1, and 2, and this is the meaning: non-drink, drinks, non-interference. I'm going to convert this 0, 1, and 2 into the codes non-drinker, drinks no interference, or drinks possible interference. I'm going to create a very, very long list of all of the codes I need to convert, as you can see. Yeah. And the system will read this entire table and will do all of these code list conversions automatically. Yeah. So as you can see, what we're trying to do is we're trying to automate a very, very important part of the process. Yeah. Source data definition, it's more used internally. Yeah. This source data definition, our mappers are using that to ensure that every single variable has been either mapped, is left empty, or has been confirmed. Why are we doing that? To make sure that we do not miss or do not forget about every single source variable that we use. There is a list with computational algorithms. Yeah? So I'm going to, that BMI, for example, equals weight divided by height squared. This is what we call a definition of a computational algorithm. There is an automatic table for the Fourier conversion, and there are some XML parameters. What are these XML parameters? These are a number of small variables, I would say, that are needed, yeah, to create my defined XML. Yeah, for example, this is a study name. There are also some dictionary references over there. So this metadata is needed to create my defined XML. So this is basically the heart of our conversion. Okay. So let me go back to the tool. I've just shown you where all of this metadata that you see here, how we have created that. It's actually created starting from the mapping sheet. Yeah. I can also show you, for example, the demographics table. Yeah. Show you the properties. See, all of my metadata is in there. Okay, and also my metadata for my table is in there. This covers the target data. Yeah. What I would like to show you now are the actual jobs, the actual macros or the actual code that are doing these conversions. I'm going to show you a very simple job at first. I'm going to show you the DM job. Now we have chosen, you don't have to do that, but our strategy is to create one job or one macro, you could say, for every target table. Yeah. So what can we see? Let's open a job like this. Now, particularly in this tool, it looks quite interesting, a job like that. It's a very typical ETL tool. Yeah. What you can really see over here is elements. Yeah. The PAT-D table. Do you remember that? That's really the PAT-D table that we've looked at together. When we looked together at the source data folder, we looked at the PAT-D table. The only thing you have to do in this tool is you have to drag and drop, and there's your PAT-D table. That's how simple it is. Yeah. Now, I hope I didn't break it, because I'm not really a heavy-duty programmer. So that is how you can drag and drop source tables in this tool. Yeah. But also my target table, the demographics target table, which I just created, I'm going to drag and drop it in this environment. Okay. And then there are a number of things in the middle. And these things over here are what we call codes. Yeah? These are building blocks. So as you can see, there's a piece of code over here that will extract my data from the PAT-D table. Then there's a standard piece of code, a code list converter. As you can see, it has a certain inversion. Yeah. So it's a code list converter. What will it do? It will read information from the patient table. It will also read that full code list table. That full code list table is coming from my mapping sheet, in fact. Yeah. It will read a number of tables, and it will automatically convert all of my code lists. You can see that I'm going to do a number of joins with reference dates. So a joins between tables. Then there is a building block which is going to do my ISO 8601 automatic datetime conversion. Then there is another extract apparently, and finally I'm going to load this into demographics. So as you can see, it's a relatively simple building block. Now this is based on SAS. A number of tools out there will run on Oracle, but the interesting thing about this entire job, when I push on code, I can actually see the SAS code. So this tool has an advantage, because what it will do for us, it will automatically generate the documentation, but also the code. So all of these building blocks, what they actually do is they generate this code. And as you can see, even though it's a very simple conversion, it generates quite a lot of code, about 1,500 lines. I'm pretty sure if you don't use a tool like this and you use simple SAS macros, you could do this much faster and with much less code. But this is how the tool works. We can take this tool, we can take this job and run it and see what happens. As you can see, a number of things are running. Oops, I only ran the first box, so I need to run everything. There's an extract part running. Yeah. I believe the code list conversion is running. Probably. Ah, this one, sorry. I did it wrong again. So let me put this. Code list conversion is running. Oh, very fast. The join, the date time, extract, everything has run. Over here I can see a status. I can see that all of my jobs have run successfully. I can have a look at warning and errors. Everything looks good. Yeah. Finally, here's my target table. So right now I can open it, and indeed I can see a nicely converted SETM dataset. Just what I want. 242 rows. That's also what I expected. I'm going to show you one more job. This time a slightly more complex job, the one from vital signs. Because in the vital signs job, I already know that I'm going to need to auto-transpose or automatically transpose data from the patient table and from the vital signs table. So if you log out a little bit, you can see that this is already a much larger and slightly more complex job. Yeah. Again, over there, my source tables are in there, patient table and the vital signs table. Quite a lot of reference tables over here. Reference table for my value level metadata, which is going to be used for my auto-transpose. See? And there is a box over here, auto-transpose. Now a little bit more about those boxes. Yeah. In this environment, there are a number of transformations. And many of the transformations are already out of the box. Things like an automatic append, a data transfer, a lookup, and a sort. All of this is coming out of the box. However, what you can do in a tool like this, yeah, you can also add a number of custom codes. Yeah. Over here, for example, auto-transpose. This is really code which we create once and we use over and over again. In fact, specifically for this auto-transpose, I can actually see the code only for this one. Yeah. So this is an auto-transpose job, which will automatically take variables and transpose it, yeah, into records. The job we can use over and over again. So let me open it up again. So let's have a look at how this runs. I'm going to zoom out a little bit so we can follow along. Yeah. I'm going to press run. As you can see, the system is taking piece by piece and it's executing all of the jobs. Apparently, all of these different parts have run successfully. This is great. Over here, I can see the complete code for the entire job. Yeah. Again, quite a lot of code. In this time, 2,600 lines. And also, I can have a look at the log. Even though over here, I see that everything completed successfully. Over here, my complete log of everything, yeah, has been logged there. There are some nice features. I can have a look at some of the statistics. If you can see that some of your jobs are running very, very slow, you can see, okay, what's my problem? Is there an I/O problem or a CPU problem? So that's what this tool can do for you. Basically, that's about it. That's our methodology. This is how we convert data. There's one more thing I would like to show. Really, the last thing is also there are a number of supporting jobs over here, and one of them is called creating the defined XML. You can also see that there is a supporting job, for example, to create my XPT files or to create a QC content document, which is basically a document which will allow me to do better QC. I'm going to show you the defined XML file. This defined XML job, again, is pre-programmed. Yeah? So what we're basically doing is we're extracting the metadata from this tool again, and we're generating a defined XML. Again, over here, I created this once, yeah, and as you can see, quite a lot of code, all of this code generating my defined XML. Yeah. You can recognize some things over there. You can see that we are using things like, yeah, I would say complex SAS code, none of which I understand. I'm sorry about that. So what I'll do, I'll go back to the diagram and I will run this. Yeah. So in the meantime, this is running. Yeah. So let's have a look at one of my folders over there. Yeah. So I'm going back here to my folders. I made a shortcut to the tabulation folder. When I open that tabulation folder, you can see that all of my data sets are in there. Yeah. Also, my define XML is in there. Now, as you can see, at 10:54, it's earlier here in Europe, I have just created that define XML. Yeah. I can double click it, and hopefully, yeah, there we go. Here we go. It opens. So over here, there's my define XML. All of the metadata, which has been extracted from my mapping sheet into my environment, and from my environment, programming environment, into this define XML. I can see my vital signs table. Yeah. So all of this metadata are my variables for my vital signs table. I can see things like origin, the comments are in there, the code lists are in there. There's also the value level metadata, which has been automatically created in my define XML. In my value level metadata, and this is something that we recognize. Yeah. The BMI, diastolic blood pressure, height, all of this metadata has been created in my define XML. Okay, that's about it for the demo. I think we're getting very close to the hour, so I'm going to have to ask Anne-Sophie to wrap up as much as she can. And in the meantime, because we're getting very close to the hour, maybe you already can come up with a number of questions or remarks if you already have them, so we could even address those.
At the moment, there are no questions, but if you want to ask any questions, please do so in the system during the next couple of minutes when Anne-Sophie is running through the final few slides.
Not the demo slides. I will skip through the demo slides since we're getting close to the hour, because these are basically slides that reiterate what Peter has been saying for the past 20 minutes. So these will be provided to you as a sort of reference point for what Peter has just explained live in the system. So I will skip through these and get to the last part, which is the quality control. Because of course, quality control must be done on all these type of data sets generated by this tool that we've shown to you. So this is an overview of a quality control flowchart. So you see it's very complex because quality control has to be done at multiple levels. So on the CRF, on the data sets, and on the define, and on any documentation you will be providing to the PMDA for your submission. Quality control, of course, also needs to be done on ADAM, not just SDTM, even if you generate your ADAM datasets directly from your SDTM datasets. Now, here at Business and Decision, we've highly automated our QC. So we have an electronic QC system called the Data Model Compliance Checker, which checks your data for SDTM and ADAM compliance. We also do a manual QC, as certain things cannot be QC'd electronically, and we do a QC on the consistency to ensure that all the studies within your submission are consistent. And all this QC is done on the annotated CRF, the metadata, datasets, and documents. And of course, it's supported by documentation, and you need to be able to prove that you did all of this. The DMCC tool that we use is an application that runs also in SAS. So what we do is that we read in the SDTM and ADAM datasets along with the metadata and the implementation guides, actually, the models of CDISC. We create a job that will run and will generate an exception table and compliance reports. So if we give you an example, so we've based all these checks on WebSDM checks, OpenCDISC, and the ADAM validation checks, and we've got checks for each model. And of course, this checklist is growing continuously as new models are developed by CDISC at an exponential rate. So the tool generates an exception table which will really report any issues with compliance. So for example, here we've got an original result is completed, but the standard result is missing. And it will tell you exactly which domain, for which patient, which record the error is occurring. In addition, of course, we need to do a manual QC, and that is where that QC contents job that Peter showed you comes into play. So it's basically a proc contents of your source and of your target tables to be able to compare, for example, distinct values. So here, for example, we've got the distinct values of unique subject ID and a outcome. And we can do this for ADAM datasets as well to verify the distinct values for the countries, for example, and the age groups that are present in the ADAM datasets. We also use a manual QC checklist because, as I mentioned, not everything can be checked electronically, especially if you are taking data from multiple source tables and putting it into one target table. And then we've got this QC on consistency. And so for this, we have a tool that's called Compare Metadata, which uses the metadata repository to compare the different studies within your submission. And it will provide an electronic output that will highlight the differences for you, and so where you will need to make some updates. And so that was the quality control aspect of a submission. And I see that we have some questions in the box.
Yeah, we've received 2 questions so far. So the first one, it says, this is the first time I'm reading these questions, so bear with me. It says, dataset name may be in lowercase. So can the dataset name also be in lowercase, or does it have to be in uppercase?
For the actual dataset, it can be in lowercase.
Okay, so the answer to that first question then is that the dataset name can be in lowercase as well as uppercase. And then we have another question here. What is included in the library folder next to the standard model folder in DI?
In the library folder? Ah, that library folder. Okay, that was a part in the tool. In those libraries, we will find lib names. So basically, all of these metadata objects are actually connected to SAS datasets. And those SAS datasets, we need to somehow show the tool where to find these SAS datasets. So these library folders are containing nothing more than lib names. It's a definition of library names for the tool to connect to a physical location.
Okay, so just to recap then, so lib names are included in the library folder. And the answer to the other question, dataset names can be in lowercase.
Yeah. Great.
Okay, we've got about 2 minutes left. If there's any final questions, please send them through now. In the meantime, I would like to remind you that we will provide a recording of this webinar. We will also provide these slides to you. And if you need any further information on how we can help your company with legacy data conversions, please do contact me via email, and we're more than happy to talk and discuss with you. We do have another question just come in here. How do we manage the frequent updates of CDISC terminology?
That's a very good question, because indeed, typically during a conversion project, typically for us at least, it takes between 3 and 6 months, yeah, for an effort like that. But in the meantime, your code lists are continuously updating. What we choose to do for consistency, when we are starting with a project, yeah, we are going to lock down, yeah, the version of the code list that we're working on. So basically, in that certain project or for that certain submission, at some point in time when we are ready to go for a submission, at that point in time we're going to choose the latest version of the control terminology, but we're no longer changing that during the conversion itself. So we're locking down to one version of the code list. In principle, you could continue to update your control terminology. However, that will generate a lot of extra reruns, but also extra QC. And that's the expensive part of conversion, I would say. So we try to avoid updates during the conversion.
Okay, so just to confirm, we lock down the version at the start of the project, and then we do not change it. This is the cheapest way to do it. Of course, if a client requests us to change it because there's been a major update around a special therapeutic area, we will of course do it then. But just to sort of point out what Peter said then, it can take 3 to 6 months to do one of these conversion projects, depending on how much data you have. So now is the time to be thinking about your conversion projects. Don't leave it too late.
Indeed, and I have to say, business and decision, we can do it in 3 to 6 months, but if you're not used to this, so we can still see that some companies are using the strategy to do conversions internally, then it's going to take a lot longer, because we have a proven methodology, we have set up our people and our tools around this, so we can do it relatively fast, but still 3 to 6 months, or longer.
So thank you all for attending today's webinar. I will send out the slides and a recording in the next few weeks, and please do not hesitate to get in touch with us should you require any further information or would like to discuss any projects with us in particular. And we look very forward to talking to you again soon. On behalf of Peter and Sophie and myself, thank you very much and good day.